Good morning, everyone. My name is Ashley. I'm a senior at Frisco High School studying biomedical engineering under the mentorship of Dr. Erdal Toprak. So to start off, I'm just going to tell you a little bit about myself and introduce myself. So for background, I am Korean Canadian. I moved here from California when I was in the 3rd grade, and I've been here ever since. Currently, in my free time, I spend it 2 days a week at UT Southwestern under the mentorship of Dr. Erdal Toprak, and then the rest of the week I go to work. I'm a waitress at a restaurant, and I also spend a lot of time in student council, weekends and Wednesdays. That's where I am, C107. And I also go to church on Fridays and Sundays, and then if I have any time in between all that, I play the ukulele in my free time. So my quote for this year is, "They did not know it was impossible, so they did it," by Mark Twain. I chose this quote because it's really applicable to the field of biomedical engineering, and especially what I'm studying, which is antibiotic resistance, because nothing is really sure, and that's why we experiment and discover new things, and it's always really exciting to test out new things and see if they work out or not. So what is biomedical engineering? Biomedical engineering is the application of engineering principles and design concepts for medicine and biology for healthcare purposes. Basically, to put it in simpler terms, it's just engineering and sciences combined to benefit the healthcare field. I chose biomedical engineering because I took AP Biology when I was a junior, and we attended a genetics convention, and I realized that I really liked research and stem cells, and we did a lot of experiments with bacteria culturing, viruses, and lab experimentation, and it was really interesting to me, so I chose this topic. So my first semester of ISM, I interviewed a lot of people. I interviewed 8 before I found my mentor. I interviewed plastic surgeons, computer engineers, radar specialists, robotics professors, and my current mentor is a biophysicist. And one central thing I noticed is all of them recommended I major in specialized engineering, like mechanical or electrical, rather than biomedical, and rather minor in biomedical. So my mentor is Dr. Erdal Toprak. He works at UT Southwestern. He has a PhD in computational biology and biophysics. His current field of research is antibiotic resistance and bacterial evolution. And he created a device called the Morbidostat, which is basically a sort of robot that will manipulate drug concentrations in Petri dishes to see how bacteria evolve, and you don't have to do it manually. So whenever the bacteria evolve a little bit more and develop resistance, then it'll increase the drug concentration in the Petri dish. So that is a picture of the Morbidostat, and that's a picture of my mentor, Dr. Toprak. So I go on 2 mentor visits a week, and I've been on 6 or 7 or 8, and basically what I do, most of the time I'm preparing for experiments, so I'm labeling test tubes, 2,000 to 10,000 a week, and transferring like bacteria, like yeast, into the different media concentrations, which I'll get into later. And I'm also learning processes as I go. I learn a lot every time I go, like how to culture bacteria is what I learned the first day I was there. Electrophoresis I learned last time I was there. And then I learned something called like polymerase chain reaction, which is important in every lab. And it's really interesting that I get to learn something new about science every time I'm there, because I don't really know everything, obviously. And I also realized that sterilization is really, really important. There's a lot of emphasis put when you go into the lab. Everything has to be put into fire. Everything has to be sterilized with ethanol. Your gloves, your lab station, the test tubes that you touch, you drop anything, can't pick it up. And the last thing I learned is that you get what you put into it. For sure, it depends on how many times you go to the lab, how many times you like actually participate in the experiments, and that's what you get out of the entire thing. So I hopefully will put a lot of work into it and hopefully get a lot out of it too. So this is some pictures of what I've been doing so far. The bottles wrapped in foil are the amino acid media, and they're wrapped in foil because if amino acids see light, then they pretty much die. So we wrap them in foil to keep, and you can see this as Valium. There are 20 different amino acids there, and then those are the test tubes that I label for the yeast experiment that I'm doing. And it's labeled with each amino acid 1 through 4, and then delta of the amino acids, which means everything but that amino acid. That's my station. So my current work is basically my final product is what I'm doing. I'm working with a yeast called Saccharomyces cerevisiae, which is basically budding yeast, and it's pretty much the basis of yeast that people use because they can mate with each other and consume themselves, and they're just like very, very versatile. So what we're doing is testing yeast adaptation to different environments. So 20 amino acid media, there are 20 total, and there's 1 million combinations that you can make with those, but we decided that's a lot, so we're only doing 204 combinations, and within those 204 there are 4 replicates, so 1 through 4 of the amino acid, because there are 4 types of yeast that we're doing. SC, which means synthetic complete, which means all the amino acids, N, which is none of the amino acids, and delta amino acid 1 through 4, which means everything but that amino acid. So it would be like delta serotonin and stuff. And basically what we do is every day we daily transfer the yeast from each media, and because they consume the media at night, and then the next day we'll put them in a different media because they have to eat and consume in order to live. So that's what we've been doing so far, and the results thus far are that one of the cultures have turned pink. We don't know why, but it was tryptophan, and it's just turned like a bright pink color and hasn't been growing any yeast. So we're going to test that later, but for right now, we're just like... So yeah, the yeast is not growing in tryptophan. We doubled the concentration of yeast in that one amino acid, but it's still not growing, and we don't know why, which is cool, but we'll find out. And we're hoping to see like eventual mutations in the yeast and how they adapt to the different amino acids, and hopefully like a beneficial mutation. When I made this prezi, we were on day 17 of 51. We're actually now on day 25, so we're about halfway through the final product. So now for my original work. I came up with the idea for my original work because I wanted to do something that promoted awareness for antibiotic resistance and how global the threat was. And I realized that initially I was going to do a document for like just civilians, but then I realized the root of the problem was probably physicians. I talked to Coach Goff about this and came to a consensus that doctors were pretty much the root of the problem. And I wanted to answer the question, like, why was antibiotic resistance so rapidly growing? Who was responsible for it? So I created a protocol document for doctors to prescribe antibiotics safely and effectively, just so they don't push antibiotic resistance further, and to combat it. So to do this, I did a lot of research because there was a lot of things I didn't know. So I read a lot of articles about antibiotic resistance, bacteria and viruses, and regulations, factors leading to mutations, gram-positive and gram-negative. And something cool that I realized was that one article that I read about bacteria, viruses, or just bacteria in general would lead to about 10 more articles that I had to research. Things like Teixobactin and kanamycin I wasn't really sure of, especially the names of the bacteria. So I had to really focus on that and like look into that more. One interesting thing that I learned about was something called vancomycin, which is an antibiotic that is only supposed to be used in life-threatening situations, but it's developing rapid resistance. So pretty much every bacteria that it's used against is resistant to some extent to vancomycin. And I wondered why, because it's only supposed to be used in life-threatening situations. So if it was supposed to be used scarcely, then it wouldn't have developed resistance as fast. And the reason why was because statistics show that vancomycin was being prescribed very haphazardly by doctors, and without even targeting whether it was a bacteria or a virus, and that's why it was developing such rapid resistance. That was something cool that I learned. After doing all my research, which my articles are being passed around, I had to create connections between the articles that I read. And the vancomycin idea, I actually got that from a bunch of different articles, and I put that all together and I pieced it as to why vancomycin was getting such rapid resistance. So I had to create all these connections and links, and after that I created a very rough outline with an introduction, a transition, and a conclusion. And then I just outlined all the protocol that I wanted, and I really wanted to put like evidence as to why I set that protocol, because I'm a 17-year-old teenage girl, and I don't think doctors or physicians would listen to me if I didn't provide or cite my sources. So I provided evidence. And then also create an introduction as to what antibiotic resistance was, why it was important, why it was a global phenomenon. The transition was there to explain why physicians were so important in their role in combating antibiotic resistance. And in my conclusion, I just mentioned all the solutions that were currently in work and how the physicians could collaborate to make it stronger. So here is my actual protocol document. I'm not going to read the whole thing. I'll just briefly go through it. So for my introduction, I just talked about antibiotic resistance, and I definitely cited some statistics about how it would affect the economy, how it would affect global deaths and mortality rate. I talked about how antibiotic resistance is found in different diseases such as tuberculosis, malaria, MRSA, gonorrhea, and pneumonia, especially things like septicemia, which is diagnosed wrong pretty much like 70% of the time, and doctors don't really take the time to differentiate between that. So I mentioned that for sure, and I mentioned that there are some actions being taken to combat it, but obviously not enough from the standpoint of doctors. And then I explained the role of physicians, why it was so important for them to combat antibiotic resistance and their role in it. I said they had to take into account the status of the patient, why they should act collectively rather than individually, and for their own incentive rather than a global incentive. And I also mentioned some facts that President Obama was putting into motion, like the National Security Council, to implement antibiotic stewardship in healthcare facilities, and the Bill and Melinda Gates Foundation. And then I went into my protocol. So I jumped from anything like electrical documentation to dosage to hospital staff. And I provided a reason for most of them that needed a reason, such as waiting to prescribe until it's for sure that it's a bacterial or viral infection. Because bacterial infections tend to last more than 10 days, and viral infections will only last 2 to 10, and they'll often go away. So I thought it was a good idea for doctors to hold off prescribing heavier, large quantities of antibiotics until they were sure that it was bacterial infection. And I also talked about vancomycin up there because dosage should be monitored and recorded, and not start with heavy combative antibiotics such as vancomycin. I also talked about never prescribing antibiotics over the phone because you can never fully know whether the patient has the symptoms and the side effects and past medical conditions. So it was really important that doctors try their best to consult the patient directly. But I also provided some reasons as to if they did have to prescribe over the phone, then some measures they should take. I said for sure that proper documentation was really important to ensure that there was an accurate audit and there was no misuse or misdiagnosis with the patient. I said that all doctors had to have proper training and antibiotic treatment as a prerequisite to prescribing antibiotics, because the top reason for inappropriate prescribing is that doctors have insufficient training or they have difficulty selecting the drugs to prescribe. They have insufficient use of microbiological information, and they're just not sure about how to prescribe, what to prescribe exactly with which diagnosis. I said to prescribe cost effectively, so doctors tend to go toward a familiar route, and they tend to always prescribe parenteral antibiotics when oral therapy or home IV is a suitable alternative. It's less harsh and it's cheaper for the hospital as well. And then some extra things like keep up to date and follow the clinical guidelines that are already in place for the National Institute of Health and Care Excellence, and keep electronic systems in order to enhance the safety of prescribing. So I went into pretty much everything I thought of, and there's about 20 protocol with bullet points underneath as well. And then my conclusion was basically explaining why, again, re-emphasizing why physicians were important in the role of antibiotic resistance and the other potential solutions that were already in place, such as the Obama Care Foundation and the Bill and Melinda Gates Foundation. And I said the things that could be used in the future to combat antibiotic resistance as well, such as the iChip, which is something that is used to discover antibiotics, such as Pixobactin, which is a very, very new antibiotic, which is combative towards MRSA or gram-positive bacteria. And of course, all of these solutions are only possible if doctors will cooperate and help and make sure that antibiotic resistance doesn't arise for new antibiotics such as Tixobactin. And then, of course, my works cited, and I created a bibliography. And that was my original work. And hopefully, I will do something similar and keep working on my final product, my yeast evolution. And hopefully, my original work is helpful in that as well. And thank you.